Now, before we go on, I just want to throw in here. I really should have this on here so you can see what I'm doing with the mouse when it's off screen. Um, we've looked at two events per measure. We realized that sometimes it's hard to tell the difference between 2 and 4. And when you're notating by ear in an oral theory class, in an exam situation, sometimes either answer should be acceptable because there are examples of music where it could go either way and there's not a compelling reason. And so in an example of oral theory test, I think that the grader of the reader of the test should probably be open to either one as long as you stay consistent in your answer, unless it's really obvious in the elementary examples that we gave. But the one that we didn't yet look at was triple meter. And triple meter, now you've been good at coming up with tunes, so what would a triple meter tune be that you can think of that would be a good example for just a basic, something that would
Uh,
dum da dum dum dum.
I was thinking about Casey. Dun, 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 dun,
That
dun,
okay,
dun,
that's
dun.
better. Right. Mm, let's get rid of again these accents.
But I mean, that's
The
kind
band
of
played
obvious
on.
because it's it's a
Well, that's what we
it's
want
a
is
waltz
obvious ones.
time, so it's
We do want obvious ones for now, though. Well, that's really the primary music that happens in 3/4 is waltz music. It doesn't. Let's be clear, not to pigeonhole. It doesn't have to be a waltz in 3/4, but all waltzes are in 3/4. Now, that's a dangerous statement. Most waltzes are in 3/4. Guys like Dave Brubeck might want to do something to mess that up.
it just reminds me of the scene where they say we play both kinds of music, country and western.
So let's play Casey. And the idea there again is that this accent is implied.
Casey would waltz with a strawberry blonde.
Sure. Now, could a composer write that feeling in 4/4 time? Have composers done that on purpose? Yes. And the way that you would do it, which would be a little bit annoying for the neophyte, would be this. This is called cross accenting.
Dun, 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 dun,
Ba-dee-dum, 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 etc. You can put accents in unexpected places. In advanced composition, that's a favorite thing to do. By all means, should a composer use that technique of cross accenting, fighting the notated time signature versus the perceived time signature? Yes. But in an elementary lesson, in a chapter 2 lesson on meter, should that happen? No. That should appear as 3/4 time. And then the idea of the implied accent here is built in to the choice of a triple meter.
That could be an example when you were talking about how deep I have to go. I don't think I have to go that deep.
No, that's correct. So let's simply summarize this first segment by saying in an introductory look at meter and based on the sound of the music, a composer would be better off to choose a duple meter, 2/4, a triple meter, 3/4, or a quadruple meter, 4/4, based on the phrase of the song. And the idea of the bottom note being a quarter note is related to what we most frequently see, but we understand that with the capability of computers and a pencil and piece of paper, the bottom number can be anything from an eighth note to a 16th to even a 32nd or as large as a whole note, and or a half note would be more common in the Renaissance, a whole note. But in 20th century music, we typically see, and unless are highly compelled otherwise, should stick with what's most likely to be seen so that people don't spend their time trying to figure out why something is notated a certain way and can just get started performing the music. Altitude, right? Okay, let's look at this simple time signature. Now that we,
Now that's useful. The altitude, that is useful. You should be able to do something with that.
well, that's going to go on YouTube, so now other people are going to be saying it before we can even be the first ones to say it. Simple time signature. We're going to address compound in our next series, but for now, let's look at this number of notes, and let us find the measure with the incorrect number of beats. So in order to find, this is the game, one of these things is not like the other. And what's really happening here is we have to count how many events are in each measure so we can figure out which one doesn't have the same number of events
Well,
as the other.
let's do the easiest one first. Let's do the third measure.
Okay, why is that easiest?
Because there's not anything dotted. I don't have to figure out any fractionalized versions of anything or anything.
Okay, that shouldn't be a problem though, because
Well, okay.
but let's go ahead and tell me how many. I think the easiest way to deal with a kind of random question like this is how many 16th notes are here?
One.
So there's one 16th note. Now how many 16th notes would be the equivalent of an 8th note?
2.
Okay, so right there we have 3 16th notes, just in that little segment. And how many 16th notes would be in the...
Oh, I see, because this represents 2/16.
Absolutely.
Mhm.
Okay, now how many 16ths does a quarter note represent? I'm just going with the lowest common denominator.
4.
Okay, so 4 16ths plus another 16th, that's 5 16ths, and then 2 more. There are 7 16ths in that measure.
Mhm.
Okay, so that's a measure of 7 16
That,
times.
that can't be good.
I would identify that as the weird measure.
Okay.
Okay, but, you know, that only is
But
idiosyncratic.
is that the way you would go about solving this problem, is break it down to its lowest denominator?
Absolutely, absolutely, because
Oh,
now the fact that you chose that measure made it obvious. But let's go to the first measure, okay?
okay.
How many 16ths are represented by a quarter note?
4.
Okay, and then the dot gives us how much more?
So we have 6/16.
Okay, 6, and then 2 more 16ths, that's 8.
And there's 1/16 and 1/16.
10.
And then each of these represents 2/16.
So you have a total of 12 16ths in
6,
that measure.
7, 8, 10, 12/16.
Right? So if I group those into 4s, I'm in 3/4 time. 1, 2, 3, 4, or 1 eanda. See, there's 12 divisions. So that means that there would be 6, there are 12 subdivisions. So that means that there would be 3 beats, each subdivided into 4 subdivisions. I mean, I don't have to go that far in the logic of this, but there's no reason not to. So, you know, I'm going to identify this as 3/4 time. So now now watch how it helps, though, to have done that, because when I look at the next measure, I'm going to say this. 1 and 2 and 3 and so that fits the model of 3/4 time. I'm simply saying 1 and to mean a group of 4 16th notes. So
But just to be able to continue with this
yes, we
with
can
this
continue.
approach.
Absolutely.
So this is an 8th note, and the dot adds half again the value.
So the
And
dot
so
adds
we're
a
talking about
16th.
16ths.
Correct.
So it's already 2/16,
And then the dot adds 1 more.
so it's 3/16.
Correct.
7, 8, 9.
And that does indeed render 12 16th notes.
Mm-hmm.
And we found out that this next odd measure only gives us 7, so we know that's the incorrect measure. Then we'll go to the last one and we'll just count 16ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, just as expected.